Alright guys, today we want to focus our attention a little bit at something called logarithmic integration. And what I need us to understand and remember is from the derivative we have a logarithm here, so we end up with this answer, 1 over x. Or you have this one and you end up with 2 over 2x minus 3. Things like that. So we're going to be starting from this type of answer, and we want to come back to this kind of problem. So here is going to be the end results that we're going to get. We must recognize this as a pattern form, and we will use techniques found in the substitution method to help us work out some of these integrals.
It's like the antiderivative of log.
That's the whole idea. So if I take the integral of 3 over x dx, if we turn this into an exponent property, it becomes 3x to the negative 1. When we follow the exponent rule, we say, oh, that becomes 3x to the 0th power, and divide by 0, and that doesn't work. But we also should remember that whenever we have something in our denominator to the first power, that we ought to be able to apply logarithms from our integration. Because our form happens to be u prime over u is equal to the ln of the absolute value of u plus c. So we want to generate that form from du over u. Maybe you want to write that out. If that becomes our pattern that we're trying to make, then there's a lot of different things we can do to get there. Questions about this? Do we have an answer to this original part in blue? The integral of 3 over x dx. Do I have to have the 3 there? So could I put the 3 out here?
Yes.
I guess you could.
So if I can do that, what would be my next step in terms of integration?
So,
Alright, let me ask a better question. If I'm taking the integral of dx over x, according to this formula over here, what should I arrive at? And because of the 3 out in front, it's going to be also important that we go ahead and put absolute value signs around these answers. The absolute value will be a part of the results we get for natural logarithmic integration. So 3 ln the absolute value of x plus c. Questions about that?
Not this far.
Alright. So then our challenge becomes identifying this right here, making sure we have it.
Okay, so it's the u prime over u equals ln absolute value of u plus c. That's our equation. Okay,
Yeah, that's our general format. Okay? So let's try this one. Let's just go like this.
Okay, first take the 3 out front.
So we take, yeah, we put 3 out front as a multiplier.
Figure this out by myself. Spoiler alert.
Everything that spoils math itself.
So it's 3 ln 2x absolute value of 2x minus 4 plus c.
You gotta have
Alright, now wait a minute.
3 halves on the outside. Oh, times 2 and then times reciprocal to on the other side.
Yes. Alright, hang in there for a second.
Did I do it?
Let's go ahead and let u equal this denominator. Because it's not just an x by itself, it's a quantity. And so the du associated with that dx would be?
2.
So we need in the problem 2 dx, not just 1 dx. How are we going to get there?
Can we wait?
Multiply by 2.
Well, if I multiply this by 2, don't I have to divide this by 2 to keep the balance of the equation?
Yes.
Yes. Can
Okay.
you just do that?
Well, isn't 2 divided by 2 1?
Yes.
So I multiplied by 1, didn't I?
Multiply what by 1?
We multiplied the problem by 1, right?
No.
2 divided by 2, is that 1?
Yeah, but you don't multiply the whole problem by 1.
Yes, it is.
You multiply it by 2.
No, I didn't.
How not?
Goodness, Mr. Richmond.
Some Monty Python stuff.
It's terrible. Hang in there. So we end up with 3 over 2, and then if we make this thing right here, we can replace it and say this is the integral of du over u, because the 2dx is du, and the 2x minus 4 is u. Do I have integration for that part? What is this integral?
Natural logarithm of 2x minus 4 in absolute values.
Well, that, then we replace, right? So it's 3 over 2, the ln, the absolute value of 2x minus 4 plus c. And we do anything else too?
I don't get the whole 1 thing, but I understand
Yeah,
all this. So
what
I'm
the
just
heck
gonna
was all
forget you
that
even
about?
said that.
Okay, then we'll forget about the 1 thing.
What was the point of that whole...
To make sure you knew how I got 3 halves. That was the whole point of that.
frustrated me.
Alright, let's have fun with another one.
No, not yet.
You gonna write this down?
Yes.